In previous lesson, we discussed the while loop, and now we are going to learn another similar but yet different type of loop, the for. For is another fundamental control structure in C++ that allows us to repeat some particular part of the code. So you can see that in the curly brackets after for, we have the place for the code to repeat. But unlike while loop, in the round brackets, instead of one control condition, we actually have three control parts. So the first control part is initialization. Here we initialize the tracing variable, the variable that will control how many times we execute the code in the for loop. Let's initialize our variable with the integer number 5. Then after the semicolon, you should write the condition, and while this condition is true, we are going to repeat the code in our curly brackets. And this condition, of course, should be connected with our tracing variable. So my condition will be I bigger or equal than 0. So I'm going to repeat my code in the curly bracket while my tracing variable I is non-negative. And in iteration part, we are going to specify how our control variable I will change from one iteration to another. So I'm going to write I minus minus and code to repeat. Let's just type the value of our variable I in the console. Now let's build and run our program and see the result. And you can see the result in the console. You see just countdown 5, 4, 3, 2, 1, 0. So what's happening here? I initialized my tracing variable with I equal to 5. And since my condition I bigger or equal than 0 is true, I executed this code, cout I. After the execution, I went to the iteration part, where I changed the value of my tracking variable I. I made it less with a decrement, so I now is equal to 4. And since my condition is still true, I once again execute the code, cout I equal to 4. Then once again I perform a decrement. I change I, now I is 3. My condition is true, so once again I execute code, and so on and so on. And in my last iteration, I have I equal to 0. So after I executed code cout 0, I once again change my I, and since now I is minus 1, and this condition is not true, I exited my loop. So you may think, okay, this code is actually very similar to the one we executed when we talked about the while loop. As you remember, in the while loop, we just initialized some variable with the number 5, and while j was bigger or equal than 0, we performed the next code. We typed our variable j to the console, and after this actually I can decrease our variable j using postfix here, but let's actually see that the result is equal. So here I'm going to cout for loop, and here I'm going to type while. As you understand, result of the execution will be the same. Let's build and run our program, and you can see that in the for loop we have outcome 5, 4, 3, 2, 1, 0, and in the while loop we have exactly the same result. So what's the difference between for loop and while loop, and when is better to use for loop and when is better to use while loop? Of course, in these cases they do exactly the same, but you may notice that the main feature of the for loop that we always have this tracing variable that we can change from one iteration to another. So in the for loop, we always know how many times we are going to repeat our code. As for the while loop, we can use any condition we want. And sometimes it can be some dynamic condition. Sometimes we don't know how many times we are going to repeat this code. So that's the key difference between for loop and the while loop. When you always need this tracking variable, when you always know how many times you are going to repeat your loop, it's better to use the for loop to have this control variable. But when you have dynamic condition, and when you need more flexibility, when you don't know how many times you're going to repeat your loop, in this case, it's better to use while loop. So to demonstrate you how great for loop can be when you need a tracing variable, let's solve the next task. We need to find the maximum value in array. Let's actually use a vector to store our collection, and I'm going to initialize our vector of integers with some values. And according to our task, I want to find the maximum value of our array, the maximum element. So to solve this problem, I'm going to create new variable result, and I'm going to assign our first value of our vector to the result. And now I need to compare this first value of our vector with all the next members of our vector. And if some member of the vector is bigger than the first member, we are going to assign this member that is bigger to our result. To compare our result with all the members of our vector, I'm going to use the for loop. And since the number of the first member that we are going to compare with our result will be 1, the first member, I'm going to initialize our control variable I with 1. I want to compare my A0, my result, with all the members of my vector. So I'm going to perform this comparison while our control variable I is less than I size. And in each iteration, I want to increase our control variable by 1. And if AI is bigger than result will be equal than AI. So I'm going to compare each element of my vector with our targeted value result. And if our result is smaller than this new member of our vector, result will be equal to AI. So let's check that we actually found the maximum value of our array. Let's write to the console maximum max member is, and our variable result end line. And as you understand, the maximum value here is 143. So let's build and run our program to see the result. And you can see that indeed we received result. Maximum member of our array is 123. Now let's go back to our previous example where we just typed the value of I to the console, and let's discuss in more details the initialization, condition, and iteration part of our loop. So what will happen if I skip some of these parts? Let's, for example, I skip the iteration part. I'm not going to change our value of I. What will happen in this case? To check this, let's just build and run our program to see the result. And you can see that now we have infinite loop. We just type 555 to our console again and again and again. That's because we don't have this iteration part and our condition is always true. But let's, for example, I have this iteration part, but I'll just skip the condition. What will happen in this case? Let's once again build and run our program. And you can see that now, once again, I have infinite loop where my I variable is getting smaller and smaller. But because we don't have condition, our code won't stop. One more modification you may do with your loop. You can actually skip all 3 parts. You can skip initialization, condition, and iteration. Of course, in this case, instead of I variable, we need to type something different. Okay, and what will happen in this case? I think you understand once again that because we don't have condition, we once again created the infinite loop. And once again, you can see that this loop is indeed infinite. We just type A in the console again and again and again. So this is very interesting trick you can use. You can create infinite loops, but once again, you should be very careful with that. It's always better to take care about the proper initialization, condition, and iteration in your loop, so you will have some nice and proper results. Okay, let's solve another task with vectors using the for loop. Let's say my task is to find sum of all members of some integer vector. Let's once again initialize our integer vector A with some elements. And my task is to find the sum of all members. To do that, let's first of all initialize the variable sum. Sum is now equal to 0, and I want to sum all members of my vector. To do this, once again create tracing variable I equal to 0. So I'm going to sum 0 member with our first member and with our last member. So my condition is while I is less than size of my vector, and the iteration will be I++, and the code I'm going to repeat is sum plus equal to AI. So in each loop iteration I'm going to add AI to my sum. Let's check that everything is okay. Let's type to the console sum of array and our variable sum and line, and if everything is okay, you can see that 12 plus 5 plus 1 is 18, so we expect to see sum 18, and you can see that indeed result is sum of array is 18. Now let's talk about the nested for loop. Let's once again solve this task. Find the sum of all members of vector, but instead of the linear vector, I'm going to have a two-dimensional vector. So it will be vector of vectors. I want to find sum of all members of my matrix. Okay, now in the first loop, I will be the index of the vector inside of the vector, and inside of our for loop, we are going to have another for loop that will trace the particular vector inside of this vector. So here we need to create another tracing variable j. J is equal to 0. Condition will be j is smaller than AI size, smaller than size of the vector we calculate in the particular loop, and j++. Okay, and now in this for loop inside of our first for loop, we are going to add to the sum this member of our 2D vector. So once again, we have a vector of vectors. Inside of vector, we have another vector. In the first for loop, we create a tracing variable for the different vector. So I is equal to the 0 vector, and when I is equal to 0 vector, we go inside of the second loop, and we trace this vector 0 with the second tracing variable j. And let's think what will be the sum in this case. I think it should be 25. Let's build and run our program. I made a typo in vector. Let's build and run again. And here is another typo. Let's build and run again and pray that we don't have any typos. Okay, and you can see result sum of array is 25. So you may notice that we mostly created the for loop that trace each member of our vector, of our container, and you might think that, well, there should be some simpler way how we can trace each member of particular container. And you're right, there is simpler way how we can trace each member of vector, each member of any container. This modification of the for loop is called range-based for loop. To use range-based for loop, you just use the next syntaxes. And in this case, int c, the variable we declared here, is actually the member of the container. So what we are going to do when we write our for loop like this, we are going to perform the number of iteration that is equal to the number of members of our container, of our vector A. And in each iteration, we are going to work with the next member of the vector. So in the first iteration, we are going to work with the 0 member, next iteration with the first member, and so on until we reach the last member of our container. So once again, let's write the same code, sum plus equal c, and let's build and run our program. And you can see that result is the same. Sum of array is equal to 18. So when you need to perform some for loop where you're going to use each member of the container consequently, you may use this range-based for loop, but you should remember one very important thing, that when you work with a range-based for loop, in this loop you can't delete or add new members to your container. Now, when we know about the range-based for loop, let's write another very interesting task. Let's say we're having a string and I want to count number of letter A in string. So let's initialize our string S and let's write something like hello Anna, have a great day. Okay, now I want to count the number of A in my string. So you can see that here we have 2, 3, 4, 5 A, and in our range based for the member of container will be char. So here we are going to write the condition if this char, the member of our string, is equal to A. Let's actually count both big and small a. In this case, I will increase sum. Actually, I think it's better to rename this variable to counter of A. And after we counted, let's write you have counter amount of A in string. Okay, let's build and run this program. Okay, you see I have a building mistake. Of course, I told you that string consists of chars. So when we iterate string, we need to use variable char. Let's build and run this program again. And you can see you have 6 amount of A in string. So I guess I calculated it wrong. 1, 2, 3, 4, 5, 6. Yeah, everything is okay. We have 6A, and using range based for, we calculated the amount of A in our string. Okay, guys, I hope this lesson was very helpful for you. If you still have any questions about for, maybe nested for, infinite for, or range based for, just leave it in the comment, and I'll see you in the next lesson.